Hey everyone, welcome to my YouTube channel. So our topic is theorems on proportion. We are gonna discuss what are the theorems on proportion, why we were using them, and what we were use them. So overall we have five theorems which will be applicable on proportion. Number 1 is Invertendo, number 2 is Alternando, number 3 Componendo, number 4 Dividendo, number 5 Componendo and Dividendo. So discussing one by one, starting from Invertendo. So number 1 is theorem of Invertendo. What we have to do in theorem of Invertendo, like if I have A ratio B is equals to C ratio D, then I am applying theorem of Invertendo. It will be written as B ratio A is equals to D ratio C, which means ratios will be inverted, ratios will be reciprocal to each other, and we have to write our answer in this form. What we were doing in theorem of Invertendo? In theorem of Invertendo, we were doing the ratios, both ratios of proportion will be inverted, both ratios will be reciprocal to each other. Like I will write it into a fractional form. A upon B is equals to C upon D. Then by using theorem of Invertendo, it will be B upon A is equals to D upon C, and then I will write it into a ratio form. It will be written as B ratio A is equals to D ratio C. So in theorem of Invertendo, we have to reciprocal, we have to invert both ratios with their antecedent and consequent, or you can say that first proportion will be inverted by second proportion and third and fourth will be inverted by each other. Okay, moving towards the next one, which is theorem of Alternando. Number 2 is theorem of Alternando. So according to the statement of theorem of Alternando, we have if A ratio B is equals to C ratio D, then A ratio C is equals to B ratio D. What we were doing in this one? In this one we can see that it will not swap with their ratio, it will be swapped with the alternative ratio. Means A goes with C and B goes with D. They were choose alternative ratios to swap their places, to invert their places. So we can say that in Alternando we have to swap, we have to invert our ratios by the alternative ratios. In a proportional question, how can we do that? Just proving this one, like if I have to write this one in a fractional form, that will be A upon B is equals to C upon D. Then it will be become like AD is equals to BC by choosing alternative, or you can say that cross multiplication. Then we have to divide it. C and D on both sides. Why I am dividing by C and D? Because it will choose alternatives now, so I have to multiply by C and D. AD upon CD, we have to divide it, and then BC divided by CD. So C cancel out by C and D cancel out by D, and I have my answer as A upon C is equals to B upon D, which will be written as in a ratio form, in a proportional form, like A ratio C is equals to B ratio D, and this will be proved by this one. Why I am multiplying it by over here? Because there is no way to solve it other than the cross multiplication. By using cross multiplication, we have to convert it into a general statement, and then we have to verify our theorem that how it will be possible. So this one is the theorem of alternando, that whenever we have theorem of alternando, we have to apply it in proportional questions. So we have to take alternative ratios to make pair of them, or you can say that ratio of them. Moving towards the number 3, which is theorem of componendo. Number 3, theorem of componendo. So according to the statement of theorem of componendo, we can say that if A ratio B is equals to C ratio D, then A plus B ratio B is equals to C plus D ratio D. This will be their statement. So how can we do that? We can simply solving it, converting it into a fractional form like A upon B is equals to C upon D, and then we have to add 1 in it by adding 1 on both sides. By adding 1 on both sides, what thing will be happen? Why we were adding 1? Because with the addition of 1 we have to take LCM, and there will be no effect on whatever we were having a variable when we were taking the LCM, and it will be multiplied by the numerator, so it will be not affected on our variable. Other than 1 we can take any number, so it will be converted my b into 2b or 3b or 4b or 5b whenever we will taking the LCM. So it will be written as a plus b upon b is equals to c plus d upon d, which is this one. According to the statement of theorem of componendo, what we have, a plus b upon b is equals to c plus d ratio d. So this one is the formula of, this one is the theorem of componendo, or we can apply it a theorem of invertendo to invert it, that my numerator will become as denominator and my denominator will become as numerator. Okay, so this one is the easiest theorem and most using theorem. Now moving towards the fourth one, which is theorem of dividendo. According to the statement of theorem of dividendo, they were saying us that if a ratio b is equals to c ratio d, which is a general proportional statement, then it will be written as a minus b ratio b is equals to c minus d ratio d. Now instead of plus we were using minus over here. It means we have to subtract 1 on both sides like we have done in componendo. So over here writing it into a fractional form, a upon b is equals to c upon d, subtracting, or you can say that subtract 1 on both sides. So by subtracting 1 we have to take LCM, and by choosing 1, by subtracting 1, my numerator will not be affected and my answer will come in an easy way according to the statement of theorem of dividendo, c minus d upon d. So this one is the statement. According to that, they were saying that a minus b is ratio to b equals to c minus d ratio to d, and there we have proved that by subtracting 1 my theorem of dividendo is proved. Now moving toward the fifth one, which is the most important theorem of proportion. So number 5th is, and the last one is, theorem of componendo and dividendo. So what we have to do, we have, according to the statement of theorem of componendo and dividendo, we have the general statement of proportion, which is A ratio B is equals to C ratio D. Then according to the theorem of componendo and dividendo, we have to say that A plus B ratio A minus B is equals to C plus D ratio C minus D. Okay, so what they were doing in that, writing it into a fractional form, A upon B is equals to C upon D. So what we have to do to make it in this form, we have to add our denominator by numerator, which is A plus B, and then we have to minus our numerator by denominator. As we learned it yet before, that in componendo they will be added and dividendo they will be subtracted. So by combining both of them, once I have to write it by addition sign and once I have to write with subtraction sign. Similarly, doing on other hand, C plus D upon C minus D, or you can use the theorem of invertendo. So you can invert that as A minus B upon A plus B and C minus D upon C plus D. So these are the theorems of proportion which will be helpful to solve the proportional questions whenever we have a question of proving the proportions. So we have to apply these theorems in our questions to get the answer. Hopefully you enjoyed this video, and this video is very helpful for all of you. So please like this video, share it with your friends, and subscribe to my channel. Take care everyone. Goodbye.